Hello everyone, and once again I welcome you all to the course on manufacturing method. So in the previous classes we have already discussed about the metal forming and pressure processes, and there we have seen about different introduction and what is forming process, what are the classifications, all those things. Okay, so then hot warming, cold warming, wall warming, etc., etc. Then we have discussed about the rolling process. Okay, so in the rolling process we have already in the previous classes we have already discussed about all those, what is, we have defined rolling process, we have seen what are the characteristics of rolling process, so how this flat rolling works, how this shape rolling works, what are the different properties of it, what are the different products that can be manufactured, and similarly the different terminologies with respect to flat rolling process. There we have seen all those entry length or exit length. Okay, point and exit point, contact length, so draft, etc., all those things we have discussed. So there we have discussed about the frictional forces that is involved in the rolling process, what is draft, how it can be defined, etc. Then later on we have discussed about the roll forces and what is the power requirement, how to evaluate them, how to find out them, and we have also discussed about the different strategies to reduce the roll forces. Okay, so and we have seen about the different grain structure that changes in grain structure that occurs during the hot rolling process, what are its advantages, how we can play with the properties of the work material, that is the part material that is produced in with the rolling processes and all, what are the advantages of it. Next we have discussed about how the pressure variation occurs along the contact length. In that case we have discussed about the friction hill or the area. We have seen that the area beneath the curve, it represents the roll force. We have seen at the no slip point the pressure is maximum. It's like all those things. Okay, so today we are going to discuss about rolling strength arrangement. Also you can consider it as the different types of rolling mills. Okay, so these rolling mills are nothing but the arrangement through which basically we produce the, or we process the rolling parts, or how basically the roll basically rolling process is basically is made. So there are different rolling strands arrangement based on how many rolls are there, or maybe how they are positioned, etc., etc. So under that particular category of rolling strength arrangement, we basically have the two high rolling mills, which is the most basic one. We have the 3 high, 4 high, or so on, and similarly we have cluster rolling mills, and we have the main classification like the tandem configuration of rolling mills. So in this process, we are in this subsequent lectures we are going to discuss about those. So what is this 2 high rolling arrangement? So now this 2 high rolling means, as we have already discussed, that it is the most basic type of the rolling strand arrangement, and this is the one which generally, while representing all those figures, etc., of rolling arrangement, basically we have drawn the 2 high arrangement only. So what is the characteristics of it, or how can we distinguish, or how can I define this particular 2 high type of rolling mill arrangement? So this is the most basic rolling mill, where it consists of two opposing rolls. So we already know basically the rolls. Okay, so they are the motion of it is basically they rotate in the opposite direction. So in the 2 high configuration, basically we have only two rotating blobs. Okay, so this particular configuration is the 2 high arrangement. So this particular 2 high rolling mills, it can be either reversing type or non-reversing type. Okay, so what is this reversing type or non-reversing type? That means this particular figure, from this particular figure you can see, sorry, okay, so from this particular figure you can see basically reversing type means we can, as from this particular side, this is the entry zone. Okay, this is the exit. So reversing or non-reversing means maybe it can go like this when we'll complete one pass, then we can change the direction of these two rolls and it can be followed in this particular direction, and there will be another roll pass. So this is kind of the reversing or non-reversing. Okay, when there is no reversing process that is happening, okay, in the reverse direction, if we are not doing the process, then it is non-reversing. If we are doing so, that becomes the reversing type. Okay, so that is about the 2 high type. So now what is 3 high rolling mill? So 3 high rolling mills, basically there are 3 rolls in a vertical column. Okay, and the direction of rotation of each roll, it remains unchanged. Okay, so that means in the previous case we have seen that if we are talking about reversing, non-reversing, so in case of reversing, if previously it was like this, so in the next side, from when it is coming from this side, it should rotate like this, the roll should rotate like this, then only it will move in this particular direction. But in the case of 3 high, so it's kind of in a vertical column, there are 1 2 3 numbers of rolls, okay. And what basically happens, so this set of rolls here, one pass will be there, okay. So during this course, it is, if you only consider up to this pass, it will be something like 2 high only, okay. But vertically there will be another roll, okay, and the roll gap and all those things has to be maintained properly as per the required this one draft, okay. So next what will happen, this P1, okay, this one, okay, this particular side, it becomes the input for this particular set. So 1 2 and 3 numbers of rolls, and you have to consider about the rolling direction. So rolling direction is remains, you can say there will not be any sense. That means this one, roll 1 is rotating in this, and this should rotate in this direction. So basically it means it is rotating in this direction, so this one should rotate in this direction. So then this way your work material can move, okay. So this is 3 high arrangement. Similarly, we can have 4 high rolling mills. So here it generally uses the 2 smaller diameter rolls to contact the work and 2 bigger backing rolls behind them. So as we have already seen, as one of the strategies to reduce roll pressure, we have discussed that we can go for rolls with lower dimension, smaller dimension, and to provide the rigidity to the system, we can back it up by another 2 bigger rolls, okay. So this, owing to the high roll forces, the smaller rolls would deflect elastically between their end bearings as the work passes through, unless it is being backed by 2 bigger rollers, which are the backing rollers, which supports them. So from this particular arrangement, you can see this is the 4 high setup, okay. This is the 4 high setup. So here we have the main 2 rolls which are actually doing the rolling action, okay. These are the smaller diameter, okay, D1, okay. So and it is being backed up by another set of rolls, okay, which are the backing rolls, and their backing rolls, and their dimension is, actually the diameter is bigger, okay. So suppose D, okay, and D is greater than this D1, okay. So this is basically about this, okay. And you can see how you can visualize the rotation of these 2 backing rolls, okay, in which direction they should rotate, so that they don't hamper the rotation of these 2. So if this is rotating in this direction, that means in this side we can consider like this. So this backing roll, the upper backing roll is rotating in this direction, similarly lower backing roll is rotating in this direction, okay. So in the next we have this 2 high, 3 high, 4 high, okay. Then we can have cluster type of rolling mills, where there basically is a cluster of rolls with the smaller working rolls. So just like in the previous cases, we have already seen what are the advantage of using smaller rolls, okay. So in the case of, this is the cluster setup, so there is a cluster of rolls with all those backing rolls, okay. So this is known as, this setup is known as the cluster type, okay. Similarly, we can have the tandem configuration of rolling mills. So in this tandem configuration, basically there is it consists of a series of rolling strands, so that's to achieve the higher throughput rates in standard product, okay. So this particular tandem rolling mills, basically typical one generally have 8 to 10 different strands, okay, and all the rolling strands, it will make a particular amount of reduction in thickness, okay. Or otherwise it can go for either where we will achieve a reduction in thickness in a particular rolling strand, or either it is reduction in thickness, or we can go for the refinement of shape of the work which is passing through it, okay. Either the shape can be changed in a particular strand, rolling strand, okay, or we can reduce the thickness, okay. And with each rolling step, the velocity of work increases. Yes, that we already know, because the entry velocity and exit velocity are different, and the exit velocity is always higher than that of the entry velocity, owing to the no volume accumulation and all, which is a constant volume process. So with each rolling step, the work velocity, it increases, and there are multiple number of rolling strands. Yes, so there is a problem, the problem of synchronization of the speeds, roll speeds at each strand. It's a significant one. So if you can say, this is the setup of a, you can say it's a tandem rolling mill arrangement. So here only 3 strands are shown. So typically maybe 8, 10, 12, this number of strands may be there. So if we'll consider this strand, so this P1 is greater than that of P0. Yes, similarly here P2 is once again greater than P1. Similarly this P3 is greater than P2, which is one time greater than P1 and P1, and but they are arranged in a series kind of configuration. So we have to take care of this velocity. That means what is happening here, what is happening here, and all. We can either reduce in all those in the subsequent rolling strands. You can either reduce the thickness, or maybe you can refine the shape from previous whatever suppose shape, maybe from circular rectangular cross section to maybe circular one. Okay, so or so on. Okay, so this is basically about the different rolling strand arrangement. Next we'll be discussing about the roll passes or the roll pass design. So what is this roll pass? So we know that, so there is a series of rolling like pass that we go for receiving the final desired output. So this roll passes or roll pass design, what is this? So the input stock to a rolling mill generally is in rectangular cross section. It's a bloom or billet depending on the size, that we already know. Okay, so our intention of rolling is that we are either going to obtain a different cross section, yes, maybe reduce thickness, or maybe the shape of the cross section itself will be different. Okay, now if that has to happen, if we have to go at the or find final part geometry, then in general the job has to undergo several passes. Okay, using form rolls with a gradually changing geometry. Yes or no? Because if you are talking of getting a particular cross section and all, okay, so in a single pass generally it's not possible. Just like we have given the analogy of making roti with the balloon, in a single pass we don't generally achieve the final desired output of the thickness level and all. So here if you are talking of different obtaining different cross section, okay, not if only if it is flat rolling, it is somewhat easier. If it is form rolling or shape rolling, so then we have to take extra care so that properly we design the rolling strand. Okay, so roll passes. Now to obtain different cross section after rolling, the job has to undergo several passes, generally using form rolls with a gradually changing geometry. So this gradual changing geometry is also important. Drastically, if we don't go for changing geometry, so in a subsequent way, okay, in a gradual manner, we generally change the geometry. And the designing the sequence of the different intermediate shape and corresponding rolls, this is known as the roll pass design. Okay, because we have to know, suppose after one rolling strand, okay, what will be the shape, and that particular shape becomes the input for the second one. In the second one, how to reduce, okay, whether we are going to reduce a particular cross section or we are going to change it or so. Okay, so all those intermediate rolling shapes and the intermediate steps and the corresponding rolls which will be required to shape those intermediate steps, so making that or designing this sequence is known as the roll pass design. Okay, and in general, if we are talking about the roll pass, generally the sequence, the roll pass sequence in generally something like this. It's categorized into 3 basic types. So the first pass is breakdown pass, second is the roughing pass, third is generally is the finishing pass. So what happens in breakdown pass? It is used for reducing the cross sectional area nearer to what is basically is desired. So here we break down the initial work material to a certain type of required cross sectional area so that we can process on it. Next is the roughing pass. So here also what happens, the cross sectional area, it once again gets reduced, but along with the reduction in the only the cross section, the shape of the roll material, it comes nearer to the required final shape. Okay, here is the roughing pass. Next we'll be having the finishing pass. So these are nothing but from the name itself you can say these are like the finishing passes, final passes, which gives us the required shape of the final required shape of the roll section. Okay, so this is basically about the 3 main passes. So under these 3 main passes, there may be one second multiple number of roughing passes, subsequent passes and all, but these are the 3 categories. Okay, so this figure is actually represents this figure set of figures represents the different passes which is required for reducing a billet to a round bar. So there may be this whole intermediate steps and the required rollers. Okay, the shape rolls right now we are talking about. So designing this thing is basically nothing but the roll pass. And what is for we use for it? It is used for the roll pass, which is for reducing billet to a round bar. So we already know from a initial billet we can also shift at a round bar. Okay, so so this is the cross section. So now how can we go for it? So we can go for initial breakdown process. Okay, we can work on. So for that, maybe this and these two are the shape rule. Okay, so because you can see how we are considering this particular. Similarly, after that we can go for this kind of shaping. Okay, maybe next again, once again we will go for like that. Then you can say subsequently in all the passes we are changing the cross section area, we are reducing it, or maybe sometimes we are achieving at a different cross section and all. And finally, after the whole passing is over, so we have achieved at the final reduced round bar. Okay, so that's the thing. So this whole system depends how to make this particular, suppose the intermediate roles. Okay, what would be the intermediate shape? These are the intermediate shapes. Okay, and to achieve this intermediate shape, what kind of roles, intermediate roles we have to have? The designing the whole sequence is called as the roll pass design. Okay, so next in this particular figure we are just showing different steps in the shape rolling of an I-beam. Okay, so apart from that, like various other structural sections like channels, rails, these are also can be rolled by these kind of different processes. So here you see, so like we can have okay, so these basically these two rolls, you can see on the periphery, on the surface of it, basically some groovy and all, depending on what kind of shape we require. Okay, some form has been given or shape has been given. That's why this kind of process, this kind of can say process is known as form rolling or shape rolling, because we get a particular shape. So here you can see, so this black part, these are nothing but the kind of the product or the cross section that we are receiving here. So you can see like here it shows the different steps to obtain a particular I beam. Okay, I section beam. So during the kind of the blooming rolls that we have with the help of this basically, so you can see, so here like some groups kind of thing, it is cut on this particular surface of the roll. Okay, so there in it will be, and this particular part is in bulging up outward. Okay, so there what will happen, as you can see, two rolls we have, and in both the rolls we have this kind of, you can say, shape. Corresponding shape is made on this particular another roll. Okay, so what will happen if we are talking of working on this particular material? So the compressive force will be applied here. So this kind of shape, that means we can expect whatever is the, it's just like the die cavity kind of thing it is making. It's not the die cavity, but we are making the corresponding shape there. Okay, similarly we can, after that we can go for edging process. Okay, there we are making the edge. Okay, somewhat round and all. These are the by the help of the edging rolls. Okay, then the roughening of horizontal and vertical rolls by using these rolls. Similarly, intermediate horizontal and vertical rolls, once again we can go for like this. Okay, different shape. And you can see from this to this, gradually we are receiving at this I section, the black part. Okay, which looks like a I or H. Okay, so from actually it is I section, so this length is actually more. Okay, so like that. Next we'll be discussing about the roll piercing process. So this is not actually exactly the rolling process, but by the help of these rollers and using them in a particular way, we can even do some other operation, and that we can sometimes make the ring kind of thing. We can go for roll piercing and all. So here we'll be discussing about the roll piercing process, how by the help of using the rollers and all, separate rollers, how we can go for this piercing of this. So what is this process? So apart from normal rolling process, so several other bulk deformation process also uses the rolls to form the work part. Okay, the operations which we can do with the help of different using the different rolls and all are like, we can go for thread rolling process, whereby by rolling action of two, that means we'll have two rollers. Okay, in between the rolls, basically it's like step roll. Okay, will be the both the rolls will have the required like thread profile cut on it, and we'll be rolling the work material inside in. That means the compression etc., compressive force etc. will be there, and based on whatever was the profile of shape that was given on the Excel the rolls, okay, flat rolls and what maybe whatever be the shape. So we'll achieve some required thread profile on the workpiece. So that kind of rolling, okay, that kind of work where we use rollers, okay, this concept of this rolling is known as the thread rolling. We also have ring rolling, whereby we can make a ring, okay. So you'll see later on like how we can make a ring and all, okay. You can just go through it by yourself also, these are easy. Similarly, we can have gear rolling by rolling like bicep rolling of this gear profile by using profile of the rollers like the gear teeth profile, okay. We can also achieve gear rolling, okay. We can manufacture gears. Similarly, we can have this particular process known as this roll piercing process, where we can pierce through it, okay. So now, what is this roll piercing process? So this roll piercing is a specialist type of hot working process for making seamless thick wall tubes. So that is important. So these are seamless thick wall tubes. So it once again it utilizes two opposing rolls, okay, and so we can group them under this rolling processes, okay. So basically, what is the principle involved in this roll piercing process? So this process is based on the main principle that when a solid cylindrical part is compressed on its circumference, a very high tensile stresses are developed at the center, okay. And if the compression is very high enough, an internal crack is formed. So now that is the thing. So if some compressive forces, high compressive force is basically given on the circumference of a particular solid cylindrical part. So basically, due to that compression, so it internally some tensile stresses it will get generated, and because of that, the crack will develop there, okay. So during the very high tensile stresses develop at its center, and if the compression is very high, so internal crack will be formed, okay. So in this particular roll piercing process, basically this particular principle is used by the help of a special type of setup. So what is the setup, how we use this particular thing? The main thing is know, if we can somehow achieve the very high kind of compressive force on the surface of it, okay, in the solid cylindrical part, if we can compress it in the circumference, we can achieve a very high tensile stress in the center, and it can even lead to a crack formation, okay, internal crack. So now in this particular case of roll piercing process, the compressive stresses on the solid cylindrical billet is applied by two rolls whose axes are oriented, this is important, axes are oriented at a slight angle, generally in the order of 6 degree, 5 degree, 6 degree, or like that, from the axis of the billet, so that their rotation tends to pull the billet through the rolls, okay. That is what is important. So you can see here in this particular angle. So if you look at this particular axis of these two rolls properly, you can see that basically they are not parallel, but somewhat both of them are oriented in a slightly different way, okay. So these are the two rolls, those are working, and this is the starting cylindrical shape of this particular workpiece, okay. This is the nothing but the workpiece, and what we want to achieve basically the roll piercing process. That means we are going to form kind of seamless tubing kind of thing, okay. So now, once we know, that means because of this particular setup, we can generate high tensile stresses as the internal, and ultimately an internal crack will be formed. That means that particular internal location is crack formation. Means what? This is now very prone to, you can say, this strength is broken, okay. It is not integrity is broken, and it's kind of now strength is also very less there, okay. Now if we use a mandrel, okay, mandrel, then what we can do by using a mandrel of proper size and all, okay, it can be used there, okay, and we can use, and we can just have some movement to it, force also we can provide to it. So a mandrel is used to control the size and the finish of the hole which is created by this particular action. So the terms rotary loop tube piercing or management process, it is also used to refer this particular tube making operation, okay. So now what basically happens, you can see from this particular figure. So as because of this application of high compressive force through this particular two rolls, which are generally inclined at an angle of like around 6 degrees or so. So because of that, internally this process of crack formation etc. will be there, and we can use a particular mandrel, okay, with and so that we can very easily pierce through the center position, and whatever be the size of the hole that is required, okay, size of the opening, so we can consider the internal or external diameter. If you consider from this side, okay, then that can be achieved by using a mandrel of proper particular size, okay. Depending on this particular size, the whatever is the formation of the tube, okay, of whatever particular diameter, that can be reached, okay. So in this particular figure, first figure shows the formation of internal stresses and cavity by the compression of cylindrical part, and the second figure shows the setup which is required for the management role for mill for producing a seamless tubing, okay. So that's basically all about this particular roll piercing setup, and this particular thing, it's not the whole module for it, okay. You have to definitely go through all the other discussion that we already had in the classes, also the notes that we have provided. So thank you everyone, hope you have enjoyed the thing.